Welcome everyone to our YouTube channel. We continue proving of identities. In this discussion, we're looking at how to prove that 1 over 1 plus sine theta plus 1 over 1 minus sine theta is equals to 2 sec theta times the square root of 1 plus tan squared theta. So that is what we are looking at in this discussion. So now we'll look at the left hand side, proving to be equal to right hand side. So we have our left hand side to be 1 over 1 plus sine theta, then plus 1 over 1 minus sine theta. Alright, so we can see that there are two fractions which are adding. So what we'll do is we'll find the common denominator. So the common denominator is simply the product of the two fractions, which is in this case 1 plus sine theta times 1 minus sine theta. So now when you get 1 plus sine theta into everything here on the denominator, you'll be left with 1 minus sine theta. Now this 1 minus sine theta will come and multiply with 1, hence giving us 1 minus sine theta. Then you add this. When you have 1 minus sine theta to divide into the common denominator, it will cancel the 1 minus sine theta, giving us 1 plus sine theta, which will multiply with 1. And this gives us 1 plus sine theta, like that. Okay, so what we'll do next is we can see that this is the same as that, and we have different signs, hence giving us 0. And what we have left on top is 2. Then you say over 1 plus sine theta times 1 minus sine theta, like this. Now if we check the denominator, our denominator is in the form a plus b times a minus b, where a is 1 and b is sine theta, same as what is here. So if this is the result, what you expect is to have a squared minus b squared. So this result is called difference of two squares. So that's what I'm going to apply here on the denominator. So I'll clear this part, as it was just used for illustration purpose. So now this gives us 2. I'm continuing this on this side. So this gives us 2 all over, upon applying difference of two squares of the denominator, we get 1 squared, which is 1, then minus sine squared, like this. Now if we recall again from the Pythagorean identities, that if you have sine squared theta plus cos squared theta, the result you get is 1. And if you want to make cos squared subject, you have to subtract both sides with sine squared, and this gives us our cos squared theta to be equal to 1 minus sine squared theta. So as you can see that this here is the same as that there, and the result we get is cos squared. So we simply do our replacement, and this gives us our 2 over cos squared theta. Alright, so we'll proceed to this side. So here I'll write this as 2 times 1 over cos squared theta, as it will still give me 2 over cos squared theta. And I'll write this as 2 times 1 over cos squared theta is same as say cos theta here times cos theta, like that. And this can be written further as 2 times 1 over cos theta times 1 over cos theta, as they are the same, and they'll give you back 1 over cos theta cos theta. So now we'll continue this on the other side here. So what do I get? I'll have 2. If you recall that if you have 1 over cos theta, this gives you sec theta, and we have 2, so I'll have another sec theta. But if you check this part here, it's the same as what we have here, because that's what we want to obtain. The only challenge that we get is simply this part here with that. So this is how we can change, or rather transform sec theta into the square root of 1 plus tan squared theta. So there's no problem, because we'll be guided by identities. So we can recall that if you have sec squared theta from the Pythagorean identities, the result is 1 plus tan squared theta, such that if you want to make sec theta subject, or rather if you want to obtain sec theta, you have to square both sides to get rid of the square on the left. So square and square root goes, and this will mean that we will get sec theta to be equals to the root of 1 plus tan squared theta. So what does this give us? This now tells us, say, this can be replaced on this part here. So hence we have 2 sec theta then times square root of 1 plus tan squared theta, and this collectively is the same as that, and we can say hence proven. So this is how you go about it, proving left hand side to be equal to right hand side. Thank you, and see you in the next discussion.